few MCQs, that's a multiple choice questions based on analog integrated circuits. Okay, myself, you all know I'm Dr. Sareen, and I'll be dealing the master like multiple choice questions which are most important as a part of the university question papers. So let us now enter into this lecture. The first one, we can see over here, a differential amplifier should have collector resistors value RC1 and RC2 has. Here a question has been given to you where the differential amplifier, we all know that it has got the two collectors, and that two collectors which have been named it as here collector resistors have been given RC1 and RC2. We are supposed to find it out what will be the RC1 and RC2 values of this particular differential amplifier. So now let us see this one. Here the answer is going to be the first one out of the options which are given to us as 5 kilo ohms, 5 kilo ohms, 5 ohms, 10 ohms, 5 ohms, 5 kilo ohms, 5 kilo ohms and 10 ohms. Here the answer is first one 5 kilo ohms and 5 kilo ohms. Why? Because it has to have, any differential amplifier should have the collector resistors to be same. That is, among these options, both the RC1 and RC2 has to be same. That's why it is 5 kilo ohm and 5 kilo ohm. Let us see what could be the exact explanation for this option A. Why the option A has to be the correct answer. Here, the values of the collector current will be equal in differential amplifier. That's the reason why here the RC1 is equal to RC2. We all know that the collector currents of a differential amplifier will be same. If the collector currents are same, it means that even the collector resistors are same. If the collector resistors are different, then definitely what happens? The collector currents at two different collectors, that's a C1 and C2 at the outputs, will be different. Since the collector currents are same, it means that the resistors which are present at the collectors, two collectors of differential amplifier, will be providing the same resistance at the two different outputs of the differential amplifier, that is C1 and C2, collector 1 and collector 2. So that's why our answer is going to be first one A, 5 kilo ohms and 5 kilo ohms. Now let us see the second one. A differential amplifier amplifies. What does a differential amplifier amplifies? Here the options are given as input signal with higher voltage, input voltage with smaller voltage, some of the input voltages, none of the mentioned. So we are supposed to know here what is a differential amplifier, what does that particular differential amplifier will be amplifying. We all know that differential amplifier will be amplifying the difference of the two input voltage signals. It will be amplifying a difference of the two input voltage signals. Means what? The input voltage will be smaller, and then that smaller voltage will be amplified at the output, that is called as a bigger voltage. You are going to get the amplitudes will be varying. Ultimately, the inputs voltage signals amplitude will be smaller compared to the output voltage amplitude. So here out of this four, the answer is going to be none of this one. Answer is going to be none of this one. Why it is none of this one? Because see the reason. What is the reason here? The purpose of differential amplifier is to amplify the difference between the two signals. That's what I was telling you. The purpose of a differential amplifier is to amplify the difference between the two signals. But among the options, there is no two signals it's given. The second one, it is given as input voltage with smaller voltage. It is given as only one input voltage. It has to amplify the difference of the two input voltages, where the input voltage will be smaller only. Ultimately, the output will be magnified. That is amplified. But here, none of these options are correct. So your answer will be none of them mentioned. So the reason why it is D is correct, because the purpose, the main aim of the differential amplifier is to amplify the difference of the two input voltages. Now the third one. The value of emitter resistance in emitter biased circuit are RE1 is equal to 25 kilo ohms and RE2 is equal to 16 kilo ohms. Find the RE. So what is given to us? It is a numerical kind of question where two emitter resistances have been given, and this particular circuit is an emitter biased circuit. Okay, we are triggering the circuit from the point of emitter. So now here this particular circuit is an emitter bias circuit, and two emitters of the transistors have been given. That's a RE1 is a first transistor emitter. So it is nothing else but emitter resistance RE1 equal to 25 kilo ohms, and the second transistors emitter resistance is RE2, that is equal to 16 kilo ohms. We are supposed to find out what is the final RE. Okay, that thing we are supposed to find. So see here, now I have made here some calculations. As per that, we will try to see what is the answer. The answer will be first one 9.756 kilo ohms. The reason is that here in the emitter bias circuit, RE1 and RE2 are connected in a parallel combination. Since RE1 and RE2 are connected in parallel combination, definitely what happens, you are supposed to apply the parallel combination formulae. So what is the parallel combination formula? RE is equal to RE1, which is parallel to RE2. If you apply the formula of RE1 in parallel to the RE2, then ultimately you are going to get this value. You can see here now the circuit where there is nothing else but R1 R2 upon R1 plus R2. So apply this formula. R1 is 25, R2 is 16, and you apply in this formula, you get ultimately on simplification it is 9.756 kilo ohms. I hope it's clear to you, this particular solution. If output is measured between two collectors of a transistors, then the differential amplifier with the two input signal is said to be configured as. If output is measured between two collectors of a transistors, then the differential amplifier with the two input signal is said to be configured as. Means what they are asking you is, they are telling that this particular differential amplifier is triggered with the two input signals, and also at the same time the output is taken at the two collectors. Now we are supposed to find it out what is the correct option of this one. The first kind of configuration is called as dual input balanced output. Second one is dual input unbalanced output. Third one single input balanced output. Fourth one dual input unbalanced output. Now let us see the option which is the correct option. The correct option is, answer is A. Why the answer is A? Because here in the question it is mentioned that your differential amplifier is being given with the two input signal. It's having the two input signals, and also this differential amplifier is obtaining the two outputs. The output is measured between the two outputs. Means what? It is having the two input signals and two outputs. It means that your differential amplifier is a dual input and balanced output. It's a dual input and balanced output. Whenever there are two inputs and two outputs, we call it as dual input and balanced output. Whenever there is two inputs and one output, means you will not be having C1 and C2. You'll be either your output is measured at C1 or at C2. Means ultimately you'll be having only one output. Then we say it is a dual input unbalanced output. Even though you have got two inputs and you are getting only one output, it means your differential amplifier will be dual input unbalanced output. Let me say if your differential amplifier is having one input and two outputs. One input and two outputs means what? It's a single input. Two outputs means, always keep in your mind, it's a balanced output. Two outputs means balanced output. One output means unbalanced output. And regarding the inputs, you can clearly you can understand from this particular notation of dual and single. Now the fourth one, see, it's a dual input unbalanced output. Dual input unbalanced output. Here, okay, fine. This one has been repeated. B and D is repeated over here. It can be anyone. It could be like dual input or else single input and unbalanced output. It could be. So ultimately, the option is here out of this one. The option is dual input balanced output. Why? Because it is mentioned in the question that the differential amplifier is with two input signals and it is having the two collector outputs. So we call it as a dual input balanced output. So you can see this explanation here. When two input signals are applied to a base of a transistor, it is said to be dual input. When both the collectors are at the same DC potential with respect to ground, then it is said to be balanced output. As per the circuit diagram, you are supposed to remember, if there are two outputs C1 and C2, we call it as a balanced output. Technically speaking, whenever both the collectors are at the same DC potential with respect to ground, then it is said to be balanced output. So this is the option A is the correct one for this fourth one. Now let us go for the fifth one. A differential amplifier is capable of amplifying. A differential amplifier is capable of amplifying. First option is DC input signal only. Second option is AC input signal only. Third one AC and DC input signal. Fourth one none of the mentioned. So now let us see what is the correct option of this one. So the correct option is it can measure or it can amplify both the AC and DC signals. Your differential amplifier can measure both the AC and DC signal. Why? Because our operational amplifier is a circuit which does some mathematical operations. So it has got both the signals, AC and DC signal. So option C is the correct one. Let us see now the explanation. Direct connection between the stages removes the direct connections between the stages removes the lower cutoff frequency imposed by coupling capacitor. Therefore, because of this one, it can measure both or it can amplify both AC and DC signal. Always keep in mind, differential amplifier will amplify both the AC and DC signals. The same signal is given to both the inputs. In ideal differential amplifier, if the same signal is given to both the inputs, then the output is going to be. It is mentioned that you are having a differential amplifier. We know the differential amplifier, everyone. This is our resistor, and you will be having one transistor I am drawing with respect to this MOSFET. This is mentioned here. You are having one V1 here and the other one is V2. And here you will be opening your both the outputs at the collectors. Output C1 and C2. These are the points in between the two collectors. You will be obtaining your value, and this is your VDD. So now see what is mentioned, what is given to you. It is mentioned that you are having a differential amplifier here with both the input signals are given to you. Both the input signals are given to you, then the output is going to be. The options are same as input, double the input, not equal to 0, and it is equal to 0. Now let us see the options here. See, the option is 0. Why the option is 0? Because when you give some here voltages V1, you supply some analog signal here. You supply some analog signal, and that signal will be same in terms of its amplitude, in terms of its phase, in terms of its frequency, in all the parameters. That A1 is going to be same just like your V1 is going to be same just like your V2. Whenever these two signals V1 and V2 are same, what happens? Ultimately your differential amplifier is what? It will be taking the difference of the two input signal and then it will be amplifying it. Whenever these two signals are same, whenever these two signal V1 and V2 which has been mentioned here are same means what? Ultimately the voltages are same in all the aspects. This voltage source are same almost in all the aspect. Whenever they are same in all the aspect, the difference of these two signals will be what? That is 0. Whenever the difference of these two signals is 0, then what happens? The amplification, the difference is 0, amplification also will be 0. So ultimately the output is going to be what? Your output is going to be 0. So your answer is 0. So in an ideal amplifier, the output voltage is Vout equal to V1 minus V2 when this V1 and V2 both are equal, when this V1 and V2 both are equal, here I have mentioned here. Whenever this V1 and V2 both are equal, what happens? The same voltages are being subtracted, you get ultimately you get output to be 0. So this is your answer. The answer is D, that is 0. An emitter bias dual input balanced output differential amplifier has VCC is equal to 20 volts, beta equal to 100, VBE, that is base emitter voltage, is 0.7 volts, RE, that is the emitter resistance, is equal to 1.3 kilo ohm. Find the IE. You are supposed to find out emitter current. You are supposed to find out emitter currents, and options have been given as 7.42 milliamperes, 9.8 milliamperes, 10 milliamperes, 8.6 milliamperes. Now let us see what's the option here. Option A is the correct one. Let us see how it's correct one. Here now, explanation. Emitter current can be found out by substituting what the formula that we have studied a formula for the emitter current. The emitter current formula is what? It is VEE. It is VEE minus VBE divided by 2 RE. It is VEE minus VBE divided by 2 RE. So we are supposed to substitute over here. So here VEE, that is equal to almost equal to 20 that is 20 volts, that is VCC, it's equal to 20 volts minus 0.7. Excuse me, here the point has not come, it's 0.7. So 20 volts minus 0.7 divided by 2 into 1.3 kilo ohms. Why? Because here now it is actually, it should be point here 0.7. Why? Because it is VB is equal to 0.7. It's given to us by mistake. It has come 0.7. It should be 0.7. 20 volts minus 0.7 volts divided by 2 times of RE. What's the RE value is given to us? It is 1.3 kilo ohms. That is 2 times of 1.3 kilo ohms. When you do some mathematics over here, you're going to get your answer equal to 7.42 milliamperes. So your answer, this one is your correct answer. The only the thing is that you are supposed to remember the formulae. Different kinds of formulae which you have studied for all this AIC and ECAD, EDC, you are supposed to remember it. So ultimately your answer is 7.42 milliampere. Now let us enter into the next one. Eighth one, find IC, that's a collector current given. Some values are given to us, that is a collector emitter voltage is 0.77 volts and VCC equal to 10 volts, VBE, that's a base emitter voltage is 0.37 volts and RC is equal to 2.4 kilo ohms in dual input balanced output differential amplifier. So your circuit is equal to dual input balanced output means what? It is having the 2 inputs and 2 outputs. The output has been taken between C1 and C2. Just now I have drawn you the circuit. The output is taken between C1 and C2. And options are given to us. 0.4 milliamperes, 0.4 amperes, 4 milliamperes, 4 amperes. So let us see the correct answer here with explanation. The answer C will be the correct answer. Let us see how it is C. We are supposed to apply the formula again. What is the explanation here? Substitute the values in the collector to emitter voltage equation. We have studied this formula anyway. Here VCE equal to VCC plus VBE minus RC into IC. When you substitute in this formula, all the values are given to you. The values of this formula, you can see here, all those formulas are, all the values are given to you. VCC, you have got the value of VCC over here. You are having the VBE value is given to you, VB value is given to you, RC value is given to you, and you are supposed to find out IC, and VCE is also given to you. So all 1, 2, 3, 4. All these are known values to you, and only the unknown value is IC. You do some mathematics over here and get the IC on the other side, and all these other known values on the other side of the equation. then your equation becomes IC equal to VCC minus VCE plus VBE divided by RC. That is equal to all the values you substitute over here. Substitute the value of VCC, that is equal to 10, and that is VCE equal to 0.77 plus VB is equal to 0.37 divided or upon RC. RC value is 0.24 kilo ohms. That is 2.4 kilo ohms. When you do this simplification, you are going to end up with an answer that is 4 milliampere. So ultimately, your answer will be third one, that is 4 milliampere. I hope it's clear to you now. Then the next one, obtain the collector voltage for collector resistance RC 5.6 kilo ohm, IE, that's the collector emitter current 1.664 milliampere, and VCC equal to 10 volt for single input unbalanced output differential amplifier. You're supposed to remember what kind of configuration it is. It is a single input, only one input is given, the other input is grounded. Differential amplifier will be having the two inputs V1 and V2. Here it's only the single input and the other input is grounded. So the single input unbalanced output. Unbalanced output means what? Even the output is taken across only one collector. It is not taken across both the collector. It is taken across only one collector, means it's having only one input and one output. This differential amplifier is having one input and one output. We are supposed to find it out. What is the collector voltage of this one? Means you are supposed to find out what is the output voltage, because collector is a terminal where you get your output voltage. So that the voltage across the collector is called as a collector voltage. That is nothing else but, in fact, it is the output voltage of your differential amplifier. So the options are 0.987 volts, 0.682 volts, 0.555 volts, none of the above or none of the mentioned. Let us see the option B. The answer B is the correct one. Let us see how it is answer B. You can see here now. Explanation: substitute the given values in the collector equation which is being learned for the single input unbalanced output differential amplifier, that is VC equal to VCC minus RC into IC. I hope you remember this formula. VC equal to VCC minus RC into IC. When you substitute, all are known to us, only the unknown value is VC. So that's the collector voltage is equal to 10 volts minus 5.6 kilo ohms into 1.664 milliampere. And we know that IC is almost equal to IE. That's the collector current is almost equal to emitter current. So that's why ultimately you get an answer as VC equal to 0.68 volt. So the correct option is here. Option B is the correct one. So this is your correct option. Is it clear? Is it clear?
Yes, sir.
Now let us enter the next one. 10th one. In a single input balanced output differential amplifier, given VCC equal to 15 volt, RE is equal to 3.9 kilo ohm, VCE equal to 2.4 volt, and RE, this one is very important. It's a small RE, 250 ohms. Determine the voltage gain. Determine the voltage gain. And the options are A is equal to 26, 56, 38 and 61. And among this one, the correct option is A. Let us see how it's the correct option. A is the answer. Here now. Explanation. In a single input balanced output, what is the difference between the previous one and this one? In the previous question, the differential amplifier was having only one input and one output. But whereas this one, it is having a single input and balanced output. Balanced output means what? It is having the two outputs. So your output is taken in between C1 and C2. Your output is taken in between C1 and C2. That's why it's a balanced output amplifier. Single input means it's having only one input. So now the formula for this one is equal to IE equal to VEE minus VBE upon 2 RE. And all the values are known to you. Substitute in the values. We know that VCC equal to VEE, only it's the difference of, it's the change in the polarities. Plus VCC and minus VEE. Normally in the laboratory we might have done that plus or minus 12 volts. Means what? VCC will be plus 12 volts and VEE equal to minus 12 volts. So both are having the same magnitude. The magnitude will be same, only it's changing the sign, polarity. So that's why I have written here, it is VCC equal to VEE. So when you substitute this values here, you'll get 1.83 milliampere as a emitter current, and from the equation VCE equal to VCC plus VEE minus RC into IC, you can find out what is the RC value. Get the value of RC. RC equal to 14.3 volts minus 2.4 volts divided by 1.83 milliamperes. Your 1.83 milliamperes, when you do this kind of simplification, you will get your RC equal to 6.5 kilo ohm. And ultimately what you require the output voltage. The output voltage formula is V out is equal to RC upon RE. That is equal to, RC is given to us. What is RC? Where is your RC? RC just now we have found out here. RC equal to 6.5 kilo ohms divided by 250 ohms. That is, this value is given to us. Okay, it is 250 ohms. Whenever you substitute this value, you get ultimately 26. You are going to get ultimately 26. And this one will not be having any units. Why? Because both are the resistance. The first one, the numerator is a collector resistance. It's an internal emitter resistance. So it is equal to, R and R will be having the same ohms. Ohms and ohms will get cancelled, and the answer will be 26. So your option A is the correct one. A is the correct one. So now we have completed the first 10 MCQ of this particular analog integrated circuit or linear integrated circuit.